Hello students, I think you are well. Today we shall discuss the chapter on matrices and problems on matrices. On behalf of Academy, I Dr. Vidyut Gota just telling you will get the details of the chapter on matrices on e-learning platform, and here I am only discussing some problems on matrices, and those who have already registered, no problem, and our registration is going on, so you will register yourself. And here is also an announcement that we have arranged a few demonstration class, few subjects, mathematics, physics and chemistry on 11th June from 9:30 to 5 in our branch, Lake Town. You may mail yourself on the mail address at Lake Town, and you may contact with you have an opportunity to contact with the professors directly. And here we have also an arrangement that on online and offline classes you may contact with the professors on the respective subjects. So now we shall start the problem on matrix. So let us come to the problem. Example 1. Here they have given, if the matrix A is equal to 0 to k minus 1 satisfies A into A cube plus Ci is equal to 2i, where I is the identity matrix, then the value of k is half, minus 1, 1. Which one is correct? So first, you note that you are given the matrix A is 0 to k and minus 1. Now, I have to mention that the characteristics equation of a matrix, what do you mean by it? If you have a matrix A, if you have a matrix A, the characteristic equation is for a matrix A, you have the characteristic equation determinant A minus lambda I equals to 0. The characteristic equation is determinant of A minus lambda I equals to 0. Suppose you have a matrix A, the characteristic equation will be determinant of A minus lambda I equal to 0. Now what you are given? You are given the matrix A. So given A is equal to, given A equals to matrix 0 to k minus 1. So the characteristic equation, therefore characteristic equation is determinant A minus lambda I equals to 0. This will imply determinant A is 0 to k minus 1. So A minus lambda I. So I is the identity matrix of order 2. What is our I? I equals to identity matrix of order 2, 1, 0, 0, 1. So A minus lambda I means minus lambda, this is 2, this is k, minus 1 minus lambda, this equals to 0. So this is our characteristic equation. Now you simplify the determinant. What do you get? This will imply minus lambda, that is lambda into 1 plus lambda minus 2k equals to 0. This will imply lambda squared. 0 means null matrix. So lambda squared plus lambda, then minus 2ki equals to null matrix. So this will imply lambda squared plus lambda equals to 2ki. We have got a relation. Now, one thing is to be noted that every square matrix satisfies its own characteristic equation. This is known as Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. Every square matrix, every statement is that every square matrix satisfies its characteristic equation. Every square matrix satisfies its characteristic equation. This is our Cayley-Hamilton theorem. So we have got a characteristic equation and you are given the matrix A. So we can write as A satisfies this equation, therefore we can write A squared plus A equals to 2ki. This will imply A squared is equal to 2ki minus A. This will imply A to the power 4 equals to 4k squared I plus A squared minus 4ki A. Put the value of A square. What you have got? A square equal to 2ki minus A. So this is equal to 4k square I. What is our A square? Plus 2ki plus 2ki minus A. Then minus 4ki A. This is equal to, you can write this as 4k squared plus 2k, this into I minus 1 plus 4k into A. This is our relation number 1. Again you were given A cube, A into A cube plus 3i equals to 2i. So what is our A4? A4 is equal to 2i minus 3ai. that is our 2i minus 3a. This is the equation number 2. So comparing 1 and 2, what do you get? So comparing 1 and 2. So comparing 1 and 2, we get 4k plus 1, 1 plus 4k equals to 3. So this will imply k equals to half. So the correct option is A. Therefore, correct option is A. What we have done, again I am discussing, you were given a matrix A is equal to 0 to k minus 1, and this matrix A satisfying the given relation A into A cube plus 3i is equal to 2i, where I is the identity matrix. Then what will be the value of k? Now first we find the characteristic equation of the square matrix. Now what do you mean by characteristic equation? If A is the given matrix, the characteristic equation is given by determinant A minus lambda I equals to 0, where I is the identity matrix order 2, that is our 1 0 0 1. Now you are given that A is the matrix 0 to k minus 1. So first find out the characteristic equation. Determinant of A minus lambda I equals to 0. You are given the matrix A. From this you find the characteristic equation as lambda square plus lambda is equal to 2ki. Now one thing is to be noted, every square matrix satisfies its own characteristic equation. So here the matrix is A, so it will satisfy the characteristic equation, that is, in case of lambda put A square plus A is equal to 2ki. From it we find A square equal to 2ki minus A, and therefore A to the power 4 is equal to this thing. This is our equation number 1. Again you are given A into A cube plus 3i is equal to 2i. Simplify it. What is the value of A to the power 4? A to the power 4 is equal to 2i minus 3. This is our equation number 2. Now compare this to the equation 1 and 2. So from this you can write 1 plus 4k is equal to 3. Therefore you will get k is equal to half. So the correct option is A. Next I am going to another problem on matrix. So what you are given, the second problem is you are given A and B be any two 3 by 3 symmetric and skew symmetric matrices, then which of the following is not true? These 4 options are given, and which is not true you have to find it out. So to explain this problem, first you have to note that what we mean by a symmetric matrix and skew symmetric matrix. Now what is the first we define what we mean by the transpose of a matrix. Suppose we are given a matrix a matrix A is equal to say 1 2 3 4. What do you mean by the transpose of a matrix? The transpose of the matrix is given by rows are changed into columns and columns are changed into rows. These are rows, these two are rows, and these are columns. So A transpose of A, what will be this? A transpose means rows are changed into columns. There is 1 2 3 4. This is what you mean by the transpose of a matrix. If the rows of a matrix, rows and columns are interchanged, then we get the transpose of a matrix. Here we have taken an example. A is equal to 1 2 3 4. A transpose is 1 2 in the column, 3 4 in the second column. Now, what do you mean by symmetric matrix? First, we define what do you mean by symmetric matrix. Matrix A is said to be symmetric. Is said to be symmetric if A transpose equals to A. Here, what you are given? Let A and B be two three symmetric matrices. One is symmetric and is skew symmetric. So here you are given that A is symmetric. A is symmetric. This implies A transpose equal to A. And what do you mean by skew symmetric? The matrix A is said to be skew symmetric if A transpose equal to minus A. Here you are given that B is skew symmetric. So you can write as B is skew symmetric therefore you can write B transpose equals to minus B. This is the definition of symmetric matrix and skew symmetric matrix. Again, some properties are required. Number one is A plus B whole transpose is our A transpose plus B transpose. A minus B whole transpose is our A transpose minus B transpose. And next one is AB whole transpose equals to reverse order B transpose A transpose. So our problem is that which one is not true. So first we verify it. Number one, e to the power 4 minus b to the power 4. Whether this matrix is skew symmetric or symmetric. So first we start from here. This whole transpose, you can write this as e to the power 4 whole transpose minus b to the power 4 whole transpose, and this you can write as a transpose whole to the power 4 minus b transpose whole to the power 4. We are given that A transpose equal to A. So A to the power 4 and B transpose equal to minus B whole to the power 4. So this is a class of minus B to the power 4. So what we got? Just it is known that if A transpose equal to A, then it is symmetric. So A to the power 4 minus B the whole transpose equal to A to the power 4 minus B to the power 4. This implies that A to the power 4 minus B to the power 4 is symmetric. Is symmetric. So this is true, but you have to show that which one is not true. So first we have verified that this is true. Now come to the second one. AB minus BA. So start from here. AB minus BA whole transpose. This is equal to AB transpose minus BA transpose. Apply this formula. AB transpose is the reverse order. B transpose A transpose minus here is our A transpose B transpose. What you are given? B transpose equal to minus B. This is our minus B. A transpose equal to A minus A transpose equal to A. B transpose equal to minus B. So this is our AB minus BA. So we can say that this is also a symmetric matrix. Therefore, AB minus BA is symmetric. As because the transpose of it is a matrix itself. So second one is true. What about the third one? Start from here, b to the power 5 minus a to the power 5 whole transpose equal to, you can write b transpose whole to the power 5 minus a transpose whole to the power 5. What is our b transpose? This is our minus b. So we can write this as minus b whole to the power 5. What is our a transpose? This is our a. So a to the power 5. So this you can write minus of b to the power 5 plus a to the power 5. So we can conclude that whether it is symmetric or skew symmetric, we cannot conclude. So we cannot say that whether it is symmetric, we cannot say it is symmetric or skew symmetric. So C is not true. We want which is not true. Therefore, C is not true. If you want to see that whether fourth is correct or not, verify, let us verify. Fourth one, AB plus BA whole transpose. This is equal to AB transpose plus BA transpose equals to B transpose A transpose plus A transpose B transpose. So B transpose equal to minus B. So minus AB minus B transpose equal to minus B and A transpose equal to A, and this is our A transpose equal to A and B transpose equal to B, minus B A. So this is equal to minus of A transpose equal to A, B transpose equal to minus B. First this will come as minus B A. So this is our minus of AB plus BA. So this is our skew symmetric matrix. So this is correct, but C is not correct. So which is not true? A, B and D are true. So the correct option is C. C is not true. So we have discussed for our competitive purpose two of the problems on matrix, this number 1 and number 2, and let us discuss the two problems, and all the problems are given in our e-learning platform and also online and offline classes. You can contact with their respective teachers. Thank you.